Good then, welcome to the Math Salon. For those of you who are new, I'm Dr. Mendem. The Math Salon is intended to help students improving their mathematical skills, also help teachers and parents support their children. Today we'll be looking at solutions to the quiz that we did last week. The quiz process, for those who are new, we give monthly quiz, or as it will be maybe from next academic year, that we give maybe 2 times a term. And the idea is that I give you 10 questions that are multiple choice questions. So I give you 5 answers. If you choose the correct answer, you get a point. If you choose the wrong answer, you get -1. If you don't choose any answer, you get 0. So it is possible that you could actually get 5 correct answers, but if you also chose 5 wrong answers, then you get a 0. It's important therefore that the student solves the question before they choose an answer. Here I'm not going to write the questions anymore, so it's important that this video you watch in collaboration with the questions. So my advice would be, first look at the quiz question, take the quiz yourself, and then come and look at the solution and then score yourself. And then you'll be able to know how much you've learned in this process. I also try to pre-populate the slide this time, which means I already try to solve before I discuss, so that we don't use much time, and then also then you get to use less data than you would do. So there were a number of questions that were there, 10 of them. So we are going to look at the first 4 now. The first question was on, sequence and series. I already indicated that this has material come, and it was about an arithmetic progression. The question was asking about calculating something, given some information. You were told, for example, that the product of the second and the third term, so you see there, the product of the second and third term was -6, and that the sum of the first and the fifth term was also -6. We know that for an arithmetic progression, the nth term is given as un is u1 plus n minus 1d. I've already solved many other videos within the Math Salon channel, so you can go and watch them. Then you will see the background. There I elaborate more. But today the intention is just to give you the solution to this problem, giving as much information as possible. So if that information was given, you are then asked to look for the product of the first term and the common difference. So if this is my arithmetic progression, the nth term formula, where this one is the first term and this is the common difference. This is different from a geometric progression, where the numbers vary by a product or a ratio of something. Here we see that the numbers vary with some addition or subtraction. So you could actually, your terms could reduce or they could increase. Whatever the case, the difference between every successive 2 terms would be the same. I will call that the common difference. So if we agree that that is that, then I can say that u2 simply means just put 2 in the place of n on the right hand side. u1 stays, it has nothing to do with n. N is here, so that 2 minus 1 is 1, and 1 times d is d. And u3, you see, I'm trying to look for terms that I have information, I've been given information about. u3 is u1 plus 3 minus 1, that is that. So u3 is equal to u1 plus 2d. So I see that from here I can already make an expression for u1 by taking 2d to the other side. It becomes u3 minus 2d. I can also look at u5. u5 is u1 plus 5 minus 1, that is 4d. But I also know that I can play around. This can be u1 plus 2d plus 2d. But u1 plus 2d is u3, so I replace it there, because this can be written as u1 plus 2d plus 2d. So this part becomes my u3. If this is true, then I can take my second equation here. So the first one stays. In the second equation, I replace u1 with this. That is u3 minus 2d. So that's that. This part. And then u5 I say can be expressed as u3 plus 2d. And this is here, u3 plus 2d. I have u3 plus u3, that's 2 u3s. But minus 2d and plus 2d fall off. So from here, I can solve for u3. u3 is -3. I can, of course, use the first equation there, which is what I have here. Also, the product of u2 and u3 is -6. So that means I can get my u2 simply by dividing both sides by u3. And that's -6 over -3, and that is 2. Once I get 2 successive terms, I can just take their difference to get the common difference. So that's u3 minus u2, and that gives me -5. So my D is minus 5. If I know D, simple, I can get U1. U1 is U3 minus 2D. U3 is minus 3 minus 2 times minus 5, and that gives me 7. You were asked to look for the product of this. So it was supposed to be minus 5 times 7, and that's minus 35. And none of the answers was minus 35. So the answer for number 1 was E. Question number 2. You are given a long polynomial like this. X to the 23rd, x to 19 plus x 17, x to 18, x to the 11, x to the 7 plus x to the 5th power, and x to the 3rd power. And you were told that when you should look for the remainder when that number is divided by x squared minus 1. So if you take a polynomial and divide by a certain factor, then you should expect that your answer will give you another polynomial plus a remainder. So if we arrange it well from your factor theorem that you see, remainder theorem, this expression is very common. So this is my big F of x. So I've done that also in previous videos and some other quizzes. So you can also look back to learn more. So my big F of x can be expressed as the number with which you will divide times the answer that you get after that division plus what remains. And since this is a quadratic one, it means what remains would be a linear function. That's why I put ax plus b. This is a difference of 2 squares, so I can actually have 2 factors like this. So it means this expression is what I need to be able to get my remainder for a certain value of x. We are told to look for the remainder when x is equal to 3 and 4. So this is my remainder function that I can call r of x here. So if that is true, then I will look for, if I take f of 1, then I put 1 here, this goes to 0. So this whole of this part goes to 0, except this one. So that's what you will see there. So f of 1 is a plus b. But this function f of 1 can also be derived from here. If I put 1 here, 1 to any power is 1. So I'm going to get 1 plus 1 plus 1 plus 1 plus 1 plus 1, 8 times. That's why I have 8 here, plus a plus b. And if I take f of minus 1, because I know this one also goes, then this is minus 1 plus 1, 0. So this part disappears. Then I get here minus a plus b. And if I put minus 1 here, because they're all odd powers, the answers will also be minus, and that will give me minus 8. So I get minus 8 plus is equal to minus a plus b. I can solve these two equations for a and b. If you solve them well, you see that 2b is equal to 0. If I just take 1 plus 2, the a's disappear, then I get 2b. But 8 plus minus 8 is 0. So b is 0. And then, if I now decide to subtract the two equations, then 8 minus minus 8 is 16. And a minus minus a is a plus a, and that is 2a. And then the b falls off, and a is 8. So it means your remainder is of the form 8x. You are told to look for the remainder when x is equal to 3 on 4. So you must also substitute 3 on 4 inside this function, and you get 6. So the answer was E again there. For question number 3, this question we've already solved in 2 previous quizzes. The key is that you were told to look for the real values of x for which this equation is valid. This real function here is squared. This real is squared because you're told to look for real numbers. If I square 2 terms like that and sum them up and get 0, then it is only possible if each of them is 0. So they must be 0 together. So this can only be 0 if this is 0 and this is 0. Because if this is 0 and this is not 0, then this number cannot be. And since they are squared, they cannot be negative. So that was the idea. Once you let this go to 0 and this go to 0, you could solve. This was a simple equation to solve. You can just get the factors of x squared as xx and factors of 4, so that when you multiply you get 4, but when you add you get minus 4, that's minus 2 and that. And I get this, so x is equal to 2 here. I do a similar thing here. I see that x has 2 values. X here will solve x is equal to 2 or x is equal to 1. So it has to be at the same time. So when x is equal to 2, this will be 0 and this will be 0. So your answer was C. So you have to choose there. For question number 4, yeah, we had something to do with probability there. The idea was to, I also indicated I was going to give you something about that. So you had a bag with 3 white balls and 7 red balls. And a ball is drawn at random from the bag and not replaced. So it's important to think about drawing with replacement and without replacement. If I take a ball from a bat and replace it, means the total number of balls remain the same. So that ball can partake in the next draw. But if I take a ball and keep it away, then that ball does not exist anymore. So the total number drops. So at the first time, so there were white and red balls. So there were 3 of them that were white and 7 that were red. So in total, I have 10 balls. So the probability of choosing a white ball is 3 divided by 10 because there are only 3 out of the 10. Probability of choosing a red ball is 7 out of 10 because there are only 7 out of the 10. But now you're also told if you already did the first draw and kept it back and then you're doing it again, then you see that the total number of balls have dropped. Here now, if this road says that the first ball that you took was white, it means the number of white balls have dropped to 2 and the total number of balls have dropped to 9. You notice that each time when you sum the numerators, you should get the total of denominator, otherwise you've made a mistake on the branches of your tree. The question was that you should get the probability that the first ball is white and the second is red. That's what they say in that order. So this is the probability of white, red. That's how it had to be. So you suppose the probability of white multiplied by the probability of red, given that the first one was white. So if that's the case there, I'll just get my probability of white, this is the path, and then red. So it's just the multiplication of these two. That's how 3 on 10 multiplied by 7 on 9. And if you multiply that, you get 7 on 30. And none of the answers given was the one. So E was the correct answer. So for question number 5 was talking about factorial. This question also has come a few times in the past. You are just asked to simplify this expression, the square root of 225 factorial divided by the square root of 221 factorial. Of course, if you try to use a calculator, then you got error. And that was the intention, that you don't use it, you think. So one important property is that we should know we can actually take the root and put both of the numbers under it. You have learned that from third properties. So I can actually do this. And also, according to the definition I was given on the question, you were told that n factorial means n times n minus 1 times n minus 2 and so forth. That means 5 factorial is 5 times 4 times 3 times 2 times 1. So if I do that, I see that I can actually multiply 225 times 224 until I reach 221 factorial, and it's going to go off with this, just like I'll do here. So what I'm left is only this product and then the square root. If you do that well, then you had 49,951, and that was C. For question number 6, you were told that there were 2 cubes that were made. One is small and one is bigger. And that the bigger one is 2 times the smaller one. So the volume of the large is 2 times the volume of the small. So if we say that the side of this cube is A and the side of this cube is B, then we can actually write this. So that A to the power 3 is equal to 2B to the power 3. You are asked to look for the ratio of the small side divided by the large side. The small side is B, so I put B. From this, you can work around and see that A is just the cube root of this side. And if you do that, then the cube falls this, I'm left with B, and the cube stays on the 2. So it means my B divided by cube root of 2B, this is the ratio of the small side to the big side. And if you check well, there was also no answer among them, and that was E. If we see question number 7, you are given this expression that is here under a root sign. What we are supposed to recognize that there's a pattern. 2 plus 1 is 3, and it's going to fall off with this because these terms are all being multiplied. So this falls off with that one. This is 4, it falls off with that one. This is 5, it falls off with that one. This will fall off with another one until this will also fall off with another one. The only things that will be left will be mu plus 1 and 2. And that's why it reduces to the square root of mu plus 1 and 2. We were told that answer was 6. So if I take the square root of the square of both sides, then I get 36 here. So mu plus 1 on 2 is equal to 36. I can cross multiply, then 2 times 36 is 72. Mu plus 1 is 72, so mu is 72 minus 1, and that's 71. And the answer was D there. For question number 8, this is also a question that we've done in the past. We are given this expression and asked to write it in the standard form alpha times 10 raised to the power beta. If you also try with the calculator, you would have seen that was not possible. You would also say error. The idea was for you to know that you can always play between logarithms and exponential. So they help each other. In this case, I would try to use the idea of logarithm. So I take the log of this number. If I take the log of this number, when we don't write any base, it means log 10. Everyone knows that. So this is a log of 34 raised to the power 75. The log of a number to the power can fall in front of the log. So 75 comes in front, and again log 34. Now you can actually calculate the log 34. If you do that with your calculator, that works. And multiply by 75, you get something like 114.86. But I was not asked to look for the log of this. I was told to look for just that number. So I can take the anti-log of both sides, which means I go back to the exponential. Of course, if I have the log of a to the base b is equal to x, it means that a is equal to b to the power x. A base will always remain a base. So this will be this raised to the power that will give me my 34 raised to the power 75. So 34 to the power 75 is simply taking this base and raise it to that power. And this is that. Of course, I can split this. I know 114.86 is just the same like 114 plus 0.86. So if I do that, then I also know that if I have a power mn plus that, then this is simply m to the n times a to the n. So I can play with that and come out with this form here. So this multiplied by this. This is already the part here, so I'm left for this one. But this you can also do with your calculator, and that was 7.24. The answer for that one was B. So for question number 9, you have to simplify this expression. This has also come in some other quizzes in the past. All have to do with factorization and difference of two squares. So if you look at this expression, you see that I have minus 16 beta squared plus alpha squared divided by this. I can just swap the position to make the minus in the middle. And if I do that, I recognize immediately that this is the difference of two squares, where I can actually write this as 4 beta all that squared. If I square this now, this is 16 and that is beta squared. So the factors of the difference of two squares, simply a minus b, or a plus b, a minus b. So I'll use that here. So my a is alpha, b is 4 beta. So this is alpha plus 4 beta, alpha minus 4 beta. And below, you can just write it nicely. 4 beta plus alpha is the same as alpha plus 4 beta. So they cancel and you get alpha minus beta. So the answer for that one was A. For question number 10, it was on matrices. It was something simple. People could just read directly from their notes. But you just need to look at the solutions that I provide, or the answers that I provide to choose from with care. So if that's the case, you were told this matrix had an order m by n, where m is the number of rows, this is number of columns. And B had the order R by T. So this is the number of rows here, number of columns. You can only multiply two matrices if the number of columns in the first matrix equal to the number of rows of the second matrix. That means R was equal to n, and that was B. Thank you for the courageous students that took part in this Math Salon quiz. We will resume with the Math Salon quiz next academic year from October. So please, you are welcome to go through the Math Salon channel. There are many videos there solving different mathematical problems. I assure you, you would live without a regret. Thank you, and good luck for those who are taking GCE examinations.